Extreme Laboratory Physics.
In today's lab, we're going to be measuring the acceleration due to gravity using a ticker tape timer. It's named a ticker tape timer after Thaddeus Ticker Tape, the man who invented it. The difficulty in measuring the speed of an object in freefall is the fact that it drops so fast. It's difficult to get accurate timings. Well, thanks to Thaddeus, we can get an accurate timing right here in our own classroom. The ticker tape timer takes advantage of the fact that our AC electrical power system oscillates the supply voltage to our classroom at a 60 cycle per second frequency. Due to this oscillating power, a miniature hammer slams down 60 times per second. Underneath the hammer is a piece of carbon paper. And underneath the carbon paper, we will put a strip of ticker tape paper that will be marked every time the hammer smashes down. We attach the end of a strip of ticker tape to a weight, drop the weight, and as the weight accelerates to the floor, the paper accelerates at the same rate, leaving a dot on the paper every 1/60th of a second. Those are some fine motion dots. Let's review. Take a piece of ticker tape long enough to reach the floor. Feed the ticker tape under the carbon paper. Rip, never tear, a small piece of sticky tape and attach the ticker tape to a weight. Turn on the ticker tape timer. Drop the weight. Turn off the timer. Admire your dots. Now let's analyze our tape. We want to determine the acceleration of the tape. We will do this using the definition of acceleration. This is a constant acceleration, so all we will need is two different velocities and the time interval between these two velocities. This is the side that had a weight on the end. And you can tell that it had a weight on the end because it has a weight on the end. Remove the weight and place the ticker tape on a fine rosewood table. On the weight end of the tape, we can see where the hammer was smashing away relentlessly before the weight was dropped. There is no useful data here because the weight is not in free fall. Now, if we move down the tape a bit, we have all the hallmarks of constant acceleration, like we've been drawing in our motion diagrams. Let's choose a point early in the drop where we can clearly see the weight is accelerating and mark it. We determine the average speed between the dots by knowing the time interval in which each dot was created and measuring the distance between them. Draw a vector to represent the velocity and label it. Next, we will move a substantial distance down the tape and choose a later pair of dots to create a second velocity vector and determine its magnitude. Finally, we will determine the time interval between the velocity vectors by analyzing the dots. Now that we have all our data, we will draw a scaled vector diagram to find delta v, and from delta v, we will calculate the acceleration of the falling weight. You should get good results in this experiment. So if your numbers come out wonky, figure out what went wrong and fix it. Now, good luck. And not just in the experiment, but good luck in all that you do.
Extreme Laboratory Physics.